How many of you guys use these items pictured here? How much time a day do you spend watching TV, watching YouTube videos, or playing video games on your phone? Have you ever thought about not being able to use these things? What you might not know is that about 80% of all the voice and data traffic in the world is carried via fiber optic cables. Whether it's a phone call to your local pizza delivery place, your favorite cable television channel, or your latest online purchase, chances are it was made possible by network cable using fiber optic technology. So hello, my name's Alex. I'm a mechanical engineering major here at the University of Nebraska-Lincoln, and today we're going to talk to you about fiber optics. First, we're going to talk to you about their impact on society and how they relate to your daily life, how they work and what they're made out of, and finally, what engineers do revolving around fiber optics. So starting off, we're going to talk about the impact on society. You have all been around TVs and mobile phones, and we use them for communications and to surf the internet, right? So say I'm trying to call my friend, but she didn't answer. So I sent her a text, and within just a few seconds, my message has traveled through space and reached my friend. Wasn't that pretty fast? So that's all thanks to fiber optics that are between us and the satellites in space and between cell towers. Fiber optics has not only benefited us as users, but has also helped businesses through the rapid exchange of digital money, which makes it safer instead of carrying and transporting cash. So companies can now work together internationally, which ultimately reduces the need of traveling, which saves time and money. Fiber optics are also technology that save lives. Health experts publish journals for the health community across the world to read, communicate, and discuss health issues today. You may have heard of Allo in your local community, and they are a fiber provider for internet, TV, and phone. So this means that their services may be faster than other businesses in town because they are connected with fiber. We will see next why fiber gives you that faster connection. So moving on, like I said, we're going to talk about how it works and what it's made out of. So what's really interesting is that fiber optic cables are placed underground, even just in your own neighborhood. So this map here doesn't show what it is in the United States or in Nebraska, but this is a map of where fiber optic cables are placed on the seafloor, which is really fascinating because it shows how the whole world is connected through fiber optics. What they're made of, then, is the next question, and they are made of a bunch of wires bundled up to create a bigger cable. The very inside of each wire is made out of a core of glass, and this is just called the core, and this is what the light can bounce through to send the signals. So this is really the important part because data flows much faster by light than through a normal copper wire. And we will talk more about how that happens later. Around the glass then is something called the cladding, and this layer has a lower refractive index than the inside glass core. It reflects light back into the core, so also plays a very important role here. The cladding is then surrounded by what is called the outer coating, and this buffer coating is a protective layer that can protect from any damage done to the other layers. So in this image, that would probably be what this colored wire is, and then that second layer that we talked about is just kind of thin layer you can't really see in this image. And then the last layer, this big black bundle, is a overall protective layer that's surrounded. It's called the jacket, or the black part in the picture. So we talked about those different layers, and the core of each individual wire is made out of the glass, which refracts light signals through the cord. So the cord's also able to twist and turn, so the light signals have to have a way to get around corners. So how have you guys ever seen a periscope on a submarine? Yeah, so the periscope is not straight. You have to be able to see and out of it, and it actually bends. So one side of it is at eye level in the submarine, and one side of it is looking out. And the periscope, as you can see in this image here, has corners where there's mirrors placed, so the light travels, hitting the mirror, hitting the other mirror, and then going to the human eye where you can actually see that. And that is kind of how the light travels in the fiber optic cable. So the light is reflected here by the blue arrow, and we can see that the light bounces back and forth, and that is how the data or the light transfers through. So now we are going to talk about another concept of how that light traveling actually works. Have you guys ever seen a straw bend in water? Kind of like this. So does anybody know the reason why this happens? There's a name for it. Refraction. So similarly, fiber optics work with this same concept of refraction, and that's the phenomenon of light bending upon crossing one medium to the other. So one very important quality in calculating how much light refracts in water is the refractive index. And we have an equation to show you what that is. So the refractive index, which is the N here, it'll show you the relation between c, the speed of light in a vacuum, and v, the speed of light in a medium. And this refractive index determines how much the light ray deviates. So does anybody know what the speed of light in a vacuum is? So it's actually 300 million meters per second. So that is really fast. And to tell you how fast that really is, that's the same thing as traveling around the world almost 7.5 times in a second. That is really fast. So engineers have used this knowledge to harness the speed of light into the transfer of data. So that is really cool that there's a connection there. So to keep you guys all awake, we're going to try a little activity. I want you to try tapping one finger either on the table in front of you or on your lap 7 times, and I'm going to count to 1 second, and I want you to try to do it 7 times in 1 second. You ready? Go. 1, Mississippi, stop. Was anybody able to do it? No, maybe? Oh, somebody? Okay. Well, this just kind of shows you how fast that really is, the speed of light. So next, we are going to talk a little bit more about that refraction of the light. So as you can see on the screen, the fiber optic cable is made of 2 layers of medium with different refraction indexes. So we see the N1 and N2. So when you shoot a light ray into the fiber optic cable, you would expect maybe for it to shine right through, right? But no, actually, because N2 has a different refractive index, the light ray deviates a little bit. So that's similar to the straw bending in the water. So when you increase that angle a little bit, you end up reaching the critical angle. And you'll know you've reached the critical angle when the light that deviates actually is parallel to the fiber optic cable. So we can see there that that light blue arrow is parallel to the total cable that's going through. And when you increase the angle even more, you are going to undergo total internal reflection, similar to what we saw earlier. So it's going to actually travel through that whole cable, and that is exactly what we want. So we want an angle that ends up being bigger than the critical angle. And here's another example of that. So with this laser, we can see that when they change the angle, they're actually getting the wave to go all the way through the glass. And so again, when the angle is that big, that's where we want it to be. We want them to be able to have that light and that data to go all the way through. So now that you guys know a little bit more about how it works, we're going to talk about the different engineers and what they do around fiber optics. So not just one type of engineer works with fiber, it takes many different types working together to make it all work. So first I'm going to talk to you about civil and environmental engineers. So civil engineers can use fiber optics to make sure the structures that they make are safe. Right now, engineers have to visit sites and make manual inspections to make sure the bridges and buildings that you all interact with are safe. With fiber optics, these inspections are much easier. Because fiber optics are sensitive to stress, strain, temperature, and other things, they can constantly be monitoring these structures. And so that overall improves the safety for you guys, for all of society. Environmental engineers would work a lot more with helping to determine where the fiber optics will be placed, because as we talked about, they're put underground, they're put in the ocean, so there's a lot of places that they need to be put, and they need to be careful about where they put them. Next, the different type of engineers are mechanical and material, so that's actually what I'm studying. So mechanical engineers work with production, and fiber optic cables have to be made somewhere. So mechanical and material engineers would be the people that develop these from the earlier stages into the final product. And then lastly, we have electrical engineers. So electrical engineers would work on the physics behind the fiber optics and how those light waves run through the cables, as well as getting the wiring system set up. So now that I've told you guys about fiber optics' impact on society, how they work, and how engineers use them, does anybody have any questions?